All right, folks. The other day you learned how to identify certain qualities about a polynomial, and today I'm going to show you how to graph the polynomial on a coordinate plane. Now note that this coordinate plane does not have a grid, and that's because we're going to do a rough sketch of the polynomial. These you can make it very precise with a lot of time and with the right, with the right graph paper, with the right scale. But for what we're doing, we just want to have a general understanding of what the graph looks like. So we're not going to make it too terribly precise. We're just going to identify a few details on the graph. And so for that, we do not need a grid. And we're not going to put /1, /2, /3. We're not going to do any of that. All we're going to do is mark approximately where some of these points are. Okay? Now, the first thing that you probably want to do is put some dots in, identifying the y-intercept and then all of the roots. So what I've done here is I've already gone as far as identifying the degree, identifying the lead coefficient, identifying the roots. I've already factored it out. I've identified the y-intercept. The only thing that I haven't done here is I haven't identified the factor multiplicity. And here's what I want to show you, is that if it's already in factored form, you can identify the multiplicity very easily. You can see that the multiplicity of x minus 3 is 2, the multiplicity of x plus 5 is 1, and the multiplicity of x plus 2 is also 1. I also want you to notice that if you add up the multiplicities, I should have showed you this in the previous video, but if you add up the multiplicities, 2 plus 1, that gives you the degree of the function. So you can actually identify the degree and the lead coefficient. To identify the lead coefficient, you just multiply each of the individual lead coefficients, and that gives you the lead coefficient. So here, the multiplicity of x minus 3 has a multiplicity of 2, and then x plus 5 has a multiplicity of 1, and x plus 2 has a multiplicity of 1. So here's what we're going to do. Step 1, we're going to plot the y-intercept. The y-intercept is at 0, 90, which on a grid would be way up there. We'd have to count up 90. It wouldn't even fit on one sheet of paper, even if we turned it vertically. Okay, so what we're going to do is we're actually just going to put a dot somewhere. We're going to call that, we're going to label it 0, 90. And because we're putting a dot and labeling it 0, 90, it's officially 0, 90. It doesn't matter whether we have a grid. So we're just going to put a dot and put 0, 90. Now we want to put a dot at 3, 0. Now 3, 0 is a positive x value, and it's somewhere over here, approximately over here. We'll put a dot, and we'll put 3, 0. Okay? We're also going to put a dot at -2, 0 and -5, 0. Now -2 is approximately right here. We're going to put -2, 0. And over here is -5, just somewhere over. We know that -5 is to the left of -2. And we're going to put -5 and 0. Now once we have plotted all of our dots, we can start drawing our curve. Now here's something that you need to understand. To draw the shape of the curve, we have to look at the degree, the factor multiplicity, and the lead coefficient. And here's what I'm going to show you. Let's talk about the lead coefficient first. If the lead, oops, that's lead. If the lead coefficient is positive, then the right side of the graph is going to go up. The right side is going to be pointing an up arrow. But if the lead coefficient is negative, then the right side of the graph is going to be pointing down, a down arrow. Okay? So that's all we have to know. If the lead coefficient, it doesn't even matter what the number is. If this number is a positive number, then the right side of the graph is going to end going up. If this lead coefficient is negative, then the right side of the graph is going to end going down. And so, because this lead coefficient is a positive 1, we know that the right side of the graph is going to go up. So I'm just going to come over here, and I'm just going to draw an up arrow, because I know that the graph is going to end going up. Now the degree. The degree is interesting. The degree, we care about whether it is even or not, or odd. if the degree is odd, then the left side, the left is opposite of the right. If the degree is even, then the left is the same as the right. Here's what I mean. The right side is going up, right? If the degree is odd, then the left side would be going down, the opposite of the right side. If the degree is even, then the left side is going to go the same direction as the right side. It's going to be pointing up like that, okay? And so because this degree is 4, that's an even number, we know that the left side is going to have an arrow pointing in the same direction as the right side, which is up. So we know that the left side is going to end going up. Now we just have to worry about what's going on in the middle of the graph. Let's see what we can do here. So we handled the y-intercept. We identified or we plotted all the roots. The degree tells us, or the lead coefficient tells us which way the right side goes. The degree tells us which side the left side goes. The last thing is the factor multiplicity. If the multiplicity of a factor is odd, 1 or 3 or 5, then the curve, then the line we're going to draw crosses. It crosses the x-axis. If the multiplicity is even, it does not cross the x-axis. Now you may think to yourself, well, what in the world does that mean? Well, let me try and show you right here. If we have the x-axis here, and then we have a curve, okay, this is the x-axis, we have a curve approaching a dot, approaching a point on the x-axis. If that curve is going to cross over the x-axis, it's going to approach the dot, and then it is going to go to the other side of the x-axis. It's crossing over the x-axis. Let's say that it's coming from the bottom. What if this curves back? And it's coming at that, it's going to cross over. Crossing over means it hits the dot and then goes to the other side. Those are two instances of the curve crossing over the x-axis. And that is what happens when the multiplicity is odd. So at -5, because the factor is x plus 5, at -5 and at -2, because the factor is x plus 2, both of those factors have a multiplicity of 1. So at -2, the curve is going to cross over the x-axis. And at -5, it's going to cross over the x-axis. All right? On the other hand, if the graph, or if there's a particular point where the factor for that root, if the factor for that root has an even multiplicity like x minus 3, then the curve is not going to cross over. What it's actually going to do is it's going to approach the point and just touch the point and then turn around and go the other way. It's not crossing over the x-axis. It's just barely touching the x-axis and then turning the other way. It can also do it from the bottom. It can approach the point and then touch and then turn back the other way. This is what happens when the multiplicity is either 2 or 4 or 6 or 8 and so on, if the multiplicity is even. Okay? So in this particular case, we have to connect this end with this end by going through all these points. We have to, or touching. Like here, it's not going to go through. It's not going to cross over. It's going to go through the point and turn back because this factor has an even multiplicity. It also has to go through the y-axis. So this curve, you can either start from the left or start from the right. I like to start from the right and go backwards, but you can also start from the left and go forwards. If we start from the left and go forwards, we know that here the multiplicity of x plus 5 is odd. Therefore, the graph is going to go through and cross over the x-axis. Then we have to turn around and head back to the x-axis, because between zeros, between the roots, the curve, it may cross over, but then it has to turn around and come back so it hits the graph in the right places. So here it's going to hit, and is the multiplicity odd or even here? For x plus 2, the multiplicity is 1. That's odd, so it's going to cross over. Then it has to aim for the y-intercept, so it's got to go through there. Then it's got to go toward, it's always getting pulled towards the next point, pulled towards the next point, pulled towards the next point, okay? And it's going to come down here, and then it's going to touch, because the multiplicity here is even, so it's not going to cross over the x-axis. It's just going to barely touch the x-axis and then turn around, and then it's going to meet up. And what you're looking at here, this W shape, this is the graph of that polynomial. It's a rough sketch, and that's what you have to be able to do, okay? Let's do another one. Okay, I have another one right here. We've got this negative x minus 7 times x minus 4 squared times x plus 2 times x plus 6. Okay, and we have a y-intercept of 0 and 1,344. I've identified the lead coefficient is -1, but I haven't identified the degree or the factor multiplicity or the roots. In fact, in many cases, you don't even need to identify all that except just by looking at the polynomial. But we can identify the degree by adding up all the multiplicities. 1 plus 2 plus 1 plus 1, that's 5. So this has a degree of 5. That is an odd multiplicity. And the lead coefficient is negative, and that means something very specific. So let's start out by plotting the y-intercept. 0, I'm going to put it way up here. It's 0 and 1,344. We're just labeling it. I know it doesn't look like 1,344, but it is, because we're calling it that. We have zeros. What are the roots here? What are the zeros going to be? X minus 7 has a 0 of x equals 7, right? So we're going to put a root over here at 7. 7, 0. Then we have x minus 4 squared, and that 0 is x equals positive 4. So we know we're going to have an x-intercept at 4 and 0. Then we have x plus 2, which puts a 0 at -2 and 0. And then we have a factor, that's x equals -2. Then we have factor x plus 6, which indicates a 0 at x equals -6. And that's over here, -6 and 0. So we've got all of our points plotted. Now we've got to draw our curve. The lead coefficient is negative, which means that the graph is going to go down on the right-hand side. So we're going to go all the way over here past this point, and we're going to kind of draw a downward arrow. Okay. The degree is 5. That's odd. That means that the arrow on the left side is opposite that arrow. That arrow goes down. Odd degree means this arrow is going to go up. So we're going to come over here. We're going to draw an up arrow. And now we just got to connect them in between. We have to go through all of these points, all 5 of these points. But on the x's, we have to be careful to not cross over when the multiplicity is zero or is even. So the x minus 4 has an even multiplicity, so we're not going to cross over at 4, 0. We're going to bounce off instead. Okay? But at 7, 0, we're going to cross over. At -2, 0, we're going to cross over. And at -6, 0, we're going to cross over. So let's start from the right side here, and I'm going to draw backwards. I'm going to cross over at 7, 0. So I crossed over. Then, after I cross over and I move away from the x-axis, I have to turn around and come back to the x-axis because I have to get closer to this dot. So I'm going to turn around, come back. Now I'm not going to cross over. And since I'm not going to cross over, I want to make just kind of a neat little bump there as I'm going through the point. Now, The next 0 is over here, but before I do that, I can only cross over the y-axis at the y-intercept. And so I'm going to come up here, and I'm going to go through the y-intercept. Then here at -2, it has an odd multiplicity, so I'm going to cross over at -2. And then I got to turn around and cross over at -6. And then meet up at the arrow. This is the graph of that function f of x. Let's do maybe one more example. All right, here's another example. This one's a little bit simpler. It only has 3 factors. Each one has a multiplicity of 1. So what's the degree? 1 plus 1 plus 1, that's a degree of 3, right? We've got a y-intercept of 0 and -15. And so let's go ahead and plot everything. We'll plot the y-intercept here at 0 and -15. Then what zeros go along with these? What's the 0 that goes with x minus 5? It's +5. So over here we're going to put a 0 at 5 and 0. Then this one is x plus 1. That's at -1. So -1 is right about here. We got -1 and 0. Then we've got a factor of x plus 3 gives us a 0 of -3. This is probably right about here. That's -3 and 0. Now that we've got our points plotted, our lead coefficient is 1. That's a positive number. That means the right side goes up, right? So we've got an up arrow. The degree is 3. That's odd. That means that the left side is opposite of the right side. The right side goes up. That means the left side goes down. There we go. Now we just got to connect the arrows by going through the points. None of these has an even multiplicity, so in all of them we're going to cross over the x-axis. So here we're going to cross over. Then we got to go through the y-intercept. Then we're going to cross over here. Then we got to turn back around and cross over here. And there we go. That's the graph of our polynomial. This is a classic cubic polynomial. Up, down, up. Okay. All right. So that's it for this video. I'm going to do one more video where I just go through a bunch of different examples, and I think it should help you a good bit.